Okay, so we were talking about inverse matrices so that we can solve a system. And so remember a 2 by 2 and a 3 by 3, what their inverse looks like. We talked about the identity element. The biggest thing is that we're trying to figure out how to find the inverse matrix. It's what we need. We need that to solve the system. We need it to solve the matrix equation. So you've got to remember how in the world to figure out the inverse matrix. And basically it boils down to this aspect. Right? You find the determinant of the matrix. You do 1 over that determinant. And then you're going to multiply it times the modified matrix. You're going to swap the A and the D. You're going to put negatives in front of the B and the C. You're going to multiply 1 over that determinant times those values. And when you're done, you'll end up with the inverse matrix. That's all so that you can solve matrix equations like this one. All right, so last thing we did back on Friday was, I tried to give you an analogy over here on the left that if you had to move that 5, you'd multiply both sides by the reciprocal. I could have done it this way as well if I wanted to. You can multiply the left by 5 to the negative 1, right? The inverse of 5, which is 1 over 5. And whatever you do to the left side, do the same thing to the right. Right? And that's what we're trying to do right here. Multiply the left side by that inverse matrix. And therefore then multiply the right side by the inverse matrix. On the left, these go away. And you're just left with x. So the whole point of all this was when you multiply a to the negative 1 times a, you get the identity element matrix, which is just like 1, because remember, anything times the identity element gets you back to the original or back to x, right? And that's how we get to what we want, that x matrix. So what we're after then is trying to find the inverse so that we can move things multiplied times the matrix that we're trying to solve for. That's what we're after. That's all we're trying to do. Okay, so let's do a couple examples. All right, so this first one, you've got a matrix equation. You got the matrix 2 by 2, right? Top row 1, 2, bottom row negative 1, 2 times x. X is a matrix, right? The variable is a matrix. It's a matrix equation. What do they equal? They equal 1, 2. All right, so what do we got to do? We got to move this matrix, right? It's multiplied times the variable. We got to move it by multiplying both sides by the reciprocal. So, again, if we use a, if we just call that a, then we need a to the negative 1 times that side. And I'm going to do it in the back, a to the negative 1 times that side. Right? And that's exactly what's going to go right here, right? That inverse matrix. All right, so we got to set everything up. We got to figure out what that inverse matrix is. That's what we did on Friday. So just to be clear, we're finding the inverse of that matrix 1, 2, negative 1, 2, right? All right, so the first thing we need is the determinant. And that should hopefully, whoa, that's no good. What in the world is that? Oh, brother, this is bad. Bad example. Okay, well, we'll just use it. We'll go with it, and I'll make an adjustment, and then we'll go from there. All right, in this situation, if you do, okay. I'm thinking 0. All right, let me do what the thought is that I just did, that I just had. Okay, so if I do the determinant, right, 1 times 2 is 2, and coming back the other way, thankfully, negative 2 times a negative 1 is another 2. All right, our determinant's 4. We're okay. Let me go back to the other thought because this will give some context and something that you need to be aware of. and something that we mentioned earlier, but I mentioned it one time and mentioned it in passing. Right. My first thought when I just looked at it all of a sudden, I thought, wait a minute, the determinant is 0. That would be bad. Whenever you have a determinant of 0, you're not able to find an inverse. And if you're not able to find an inverse, you're not able to solve the matrix equation, and therefore you would conclude no solution. And that's possible. That comes up. So if I would have gotten a 0 for the determinant, then the reality would have been when you do 1 over the determinant, you have 1 over 0. What is that? Again, we talked about this probably Friday, maybe Thursday, maybe Tuesday. That's infinity. Now we have problems because we're dividing by 0. All right, not the case because we get a 4, thankfully, and we're still okay. All right, so now remember the formula. Back to right here. So again, now we've got to do this, right? We just found the determinant. So we're going to do 1 over the determinant. We're going to swap the A and the B. We're going to put negatives in front of the B and the C, or the A and the D. We're going to put negatives in front of the B and the C, and we're going to figure out the inverse. All right, so let's do that. Matter of fact, why don't you guys do that? Finish this one off. So I'll show you where we're at right now. We're at 1/4 times the matrix. And again, you're going to swap the left diagonal. So 2 goes in the top right, 1 goes in the bottom right, top left, 1 goes in the bottom right. You got to put a negative in front of that 2 in the top right. You got to do minus a minus of that -1 in the bottom right, and you're going to get 1. Okay, so that's what you're after now. And when you're done, you'll get the inverse matrix. Give you a minute. What kind of multiplication are we doing right now to finish off finding the inverse matrix? Somebody raise their hand. What kind of multiplication we do? Abigail? Scalar, right? We're doing scalar multiplication right now. So it's just the 1/4 times each element. So let me use this notation here as I keep trying to, oops, don't want to do that. So now we're finding the inverse. So again, if we're calling this A, this is A to the -1 now that we're going to end up with. So a 1/4 times 2 is a 1/2. And a 1/4 times a -2 is -1/2. And a 1/4 times 1 is a 1/4. And a 1/4 times 1 is a 1/4. All right, and that is our inverse matrix. Okay, so now we got to take that and multiply the other side by it. I'm going to use my green here. So we got a 1/2, -1/2, a 1/4, and a 1/4. 1/2, -1/2 is top row. 1/4, a 1/4 is the bottom row. Okay, so a minute ago we just did scalar multiplication. Now we're going to do matrix multiplication, right? Across and down. And we got a 2 by 2 times a 2 by 1. And the resulting matrix will be a what by what? 2 by 1, right? Again, the middles have to match. If we're able to multiply them, they do. And the result is the outside's a 2 by 1. All right, so now you got to work through across and down, across and down, across and down, across and down. I'm going to pause and let you see if you can finish it from there. And as you worked across and down, you would have had a 1/2 minus 1, or a 1/2 minus 2 over 2, and a 1/4 plus a 1/2, or a 1/4 plus 2/4. And so you end up with -1/2 and 3/4, right? Any questions on that? Again, it's a process. All right, let me let you copy that, and then I'll go back and recap. Okay, so back to the beginning. Get my purple here. All right, so you look at this and you say, oh, that's a matrix equation. And I need to isolate the variable, which in this case is a matrix. This one's pretty simplistic. There's nothing added to the variable. There's only a matrix multiplied times a variable. We've already done equations where there's a matrix added to the variable, right? And we moved it by adding the negative of that matrix to both sides. So it's possible you'll have a matrix equation where you have a matrix multiplied times a variable, and you also have some other matrix, quote unquote, added to the variable, at which case you're going to move the thing at it first by adding its opposite, just like we always do on equations. And then you'll finish it off like this one is, by moving the matrix multiplied times variable. And again, how do you do that? You need its inverse, because you're going to multiply both sides by the inverse. Again, when you get that inverse, it's going to take care of that left side, and you're isolated your variable, your matrix. So again, you got to remember, how do I go about getting this inverse? First, you need the system determinant. We did that right there. You got to remember then that the system determinant becomes a multiplier. And it goes on the bottom. It goes on the bottom. It's 1 over that system determinant. It's a scalar multiplier of the resulting matrix. And again, you got to remember, all right, I got to flip left hand, top left, bottom right, flip those. Top right, bottom left, put negatives in front. Figure out now that inverse matrix. Now that you have it, multiply the other side by that inverse matrix, and you'll get the solution. I don't think that's extremely horribly tough, but it is complicated, and you need to keep it straight. All right, I guess we went back way too many times. Come back. All right, questions again. Questions from those of you with thousands of questions. All right, none. Great. Let's do one more example. We got a word problem. Okay, you could figure out this word problem on your own. You could do it. You could play with the numbers, and you could figure out the word problem. It's not the point. The point is to try to get you used to what we're trying to do, solving with matrices, all right? So again, the point isn't getting the answer. The point is trying to figure out how to make the matrix equation so we can find the solution. That's what we're after in this case, and that's what we're trying to do. Okay, so solve the system by multiplying by the inverse. Sum of the two numbers is 8. Sum of the first and twice the second equals 10. Find the two numbers. So I'm just going to, over here, name my variable. And we got two numbers. You got a first number. You got a second number. Let's call the first number x, and let's call the second number y. Okay, so here's the easier of the two, although neither one's very difficult. Somebody give me the equation that would be that first sentence. Somebody give me that equation. Come on, participate. Participate. Julia, go ahead. Yeah, that's just x plus y equals 8, right? She summed our two numbers, the x and the y, and she said is equals, and it's 8. Okay, so that's our first equation. The second one's not extremely difficult either. The sum of the first and twice the second equals 10. So somebody give me that equation. You should all be thinking, and hopefully you are. Again, you need to think. What would I say here? All right, come on, participate. Participate. You're going to make me call on you, right? You're going to make me call. All right. I will call. Nate, is that your hand? Yeah. Go for it. X plus 2y. I agree. X plus 2y equals 10. All right. So take the first and twice the second equals 10. All right. Pretty simplistic word problem. The point is now we need to take that and we need to make a matrix equation out of it. Okay. So we did some of this already. We've taken a system like this and we've made a matrix equation out of it. We just haven't solved it before. So we've already learned, okay, take the coefficients, right? We're lined up, xy first equation, xy second equation, solution on the right-hand side. So the first row would be a what? 1, 1, and the second row would be a 1, 2. And that's pretty simplistic. Okay, there's going to be another matrix before the equal sign. But let's finish off the matrix on the right. And I think you all know the matrix on the right is going to be 8, 10, right? Okay. So does anybody remember what is this next matrix on the left? Anybody remember what we did there? Abigail? Yeah, it's the XY. It's the variables. If you had 3, it'd be the XYZ. Okay, so let me show you what we're doing here. So this right here, this XY, is like the X variable there. Because again, remember we said X was a matrix, and XY is a matrix. So what we want to do is we want to solve for XY, that matrix. Okay, so let's go off to the side because right now at this point, we know that we need to find what? What are you going to do next? What are you after? Esther? We got to find the inverse. So I'm going to come off to the right. We need to find its inverse. Find the inverse. Find the inverse. Once you find the inverse, then your next line is going to look like this, right? XY. And then you're going to have that inverse, and I'm going to leave space for it. And then you're going to have that 8, 10, right? So you're going to put that inverse right there. Abigail? It doesn't matter one bit, commutative. Wait a second. Let me think about this for a second. Yes, it does matter. Because our inverse is going to be a 2 by 2. It does, because right here we're going to end up with a 2 by 2. And this is definitely a 2 by 1. And if we do it the other way, we're going to have a 2 by 1 times a 2 by 2, which technically you cannot multiply. So the answer is yeah, because those have to match. All right, so it'll go in front. Okay, so I'm going to pause right now. What I want you guys to do, find the inverse, and then see if you can finish out the equation by multiplying that inverse to find the x and y values. All right, and the answer is 6, 2, right? Hopefully you ended up at 6, 2. All right, so again, here's the original matrix. I found its determinant was 1. That's kind of nice. Remember that determinant goes on the bottom of the scalar multiplier. Then I had to do the swapping, right? I had to swap the corners, top left, bottom right. And I had to put negatives in front of the top right, bottom left. And multiplying by 1 was kind of boring. And then when you got all that, then you had to take that, you had to take what resulted. And now that's going to be the multiplier both sides. We're just going to do it to one side. Crossing down, 2 times 8 is 16, minus 1 times 10, negative 10. Get to 6. Crossing down, negative 8 plus 10, and you get the 2. It should be doable, a little complex, but doable. Questions? All right, you got a half a period, so that's good. Take advantage of asking questions, though you are the most unquestioned people in the world, but I'm available for help. All right, you can get rolling. Abigail?